Hello viewers! Today we're diving straight into the topic without any fuss. I'll show you how to install artificial intelligence on a computer in your basement. No graphics cards needed, just a regular AMD Ryzen x86. Don't you believe it can be done from scratch in about half an hour? Let's find out. I found this box in my basement. It may not be the most beautiful computer in the world, but AI doesn't have to be beautiful, just smart, right? Instead, it has an older Ryzen 9 and 64 gigabytes of RAM on board. It also has an ancient graphics card, but it's only used for displaying image. Let's start by installing Linux on this box. I'm looking for Balena Ether. This program will allow me to burn a Linux image to a flash drive, which I will use to install it. I'm downloading version for Linux because I use Linux on my computer. But on Windows, it works the same way. It's downloaded. I need to extract this. This is a simple operation. I'm choosing Extract and Extracted. Now let me start the program. Okay, it's here. Now I need an image of Linux, but instead of choosing File, I'll deliver a URL to it. Linux has various distributions. I choose Debian, but the net install version. It's a minimalist image that installs additional packages from the network, and I don't need too much. The architecture of my Ryzen processor is x86, so I choose the AMD 64 version. I copy the link that I will use in Balena Ether. Pasted. The target drive matches, so I can start flashing. The last step is entering my password. The process will take a while, so in the meantime, we can discuss the plan. I will install Linux first. Then I plan to carry the computer back to the basement and connect to it already remotely via SSH. The next step will be to install the Ollama software. This software allows you to run large language models locally in an extremely simple way. Then we will start real experiments. We'll see how to get some small model up and running quickly, probably from the Llama 3.1 family. If that works out, I'd like to install an environment to facilitate model queries, the so-called WebUI. And finally, we will see what the largest model can be run on this hardware and how it will work. In the meantime, the writing process has ended. I'll wait a while longer until the verification is over, even if it's not necessarily needed. There will be a short break soon, because I have to connect the monitor to the computer to do a quick installation. Okay, I'll be right back. The computer powers up. I have to select boot from my flash drive. Samsung. The installation starts. This time I choose the graphics mode. Selecting language. Now my location. And locales, US English. The same for the keyboard. The installation should be rather quick and straightforward. The installer should detect components. Then connect the computer to my home network and obtain IP address via DHCP. Network auto-configured. I need to name this box. This is my sandbox for AI experiments. I don't need any domain name. Key password for the system, the root password. I need to repeat it. Now I create a regular user account. The regular user is, of course, me. One more boring password entry, but security first. Now it's time for the drives. I need to decide how to divide the disk. I'll take a bit of a shortcut and use the entire disk as one large partition. In a standard system, this is rather not recommended, but this sandbox serves only one purpose, and such a division or more lack of division will make it easier to potentially use whole disk space. After all, we know that the largest will be the language model data anyway. Of course, I have to confirm several times that I am sure of what I am doing. This is important, because partitioning the disk deletes data from it. Okay, the installation is underway, so we have some time to talk about this project. You may be wondering why Ryzen and x86. Actually, the answer is very simple. This computer was really in my basement, so there was an opportunity to use it. Very often, large language models run on Apple devices with M2 and M3 processors. They are not bad for this, especially the Pro models, but I have my own opinion about the hardware produced by this company, so I decided to try it on x86 architecture. What will come out of it? We'll see. And yes, I realize that in any case, not everyone has a spare computer with 64 gigabytes of memory in a basement. But then again, not everyone owns a Mac either. You may also wonder, why run LLM locally at all? There could be many reasons. Because you can. Because you can learn something by doing so. Because it's in all of our interests that open source projects win the race. Because you can process documents without sending them outside. And if you don't want to use it, it's at least worth knowing that it's a possibility. Installation of the base system has been just finished. I'm choosing Local Mirror to download packages from the internet. Now we have a moment's pause again for the next stage of installation. It may be worth mentioning the processor that is installed in my computer. It is a 12-core Ryzen 9 version 5900X. It is worth noting that it is a version without a graphics chip. Since I don't have a modern graphics card in my computer either, full LLM processing will be handled by the CPU. Now an important moment. I don't want a desktop environment, but I choose to install an SSH server, because that's how I'll connect to the computer. The last packages to install are downloading. We are already very close to the end of the installation. Nowadays, installing Linux is really very easy. So is its use. I would say that many elements are much more convenient than in Windows. Linux has been the primary operating system on my personal computer for a very long time. I think this is the last stage. We are installing Grub, which manages system boot. In a while I will have to disconnect again and carry the computer to the basement. Then I'll power it on and return to you. Then we'll connect to it via SSH. Okay, installation has been just finished. Let me return to you in a moment. I'm back on my laptop. I'll connect to the sandbox. This is the first time, so I have to accept the key exchange. My password from installation time. I'm logged in. Let me add user as I don't like installing anything from root. But obviously I need to be root to create the user. I assigned the root password during system installation so I know it. Now I'm sure that I can create the user. Password. Once more. Other details. And user has been created. I can add Ollama to sudo group to allow act as root. This will be helpful later. Now I can switch to this user using su command. I think we can conclude that the user environment is ready to install Ollama software. I need to look at their site to see how to install it. I'm simply searching for Ollama. And the first result is the official website. I'm choosing download button. There is a command to install the software in Linux. I'm not a fan of such solution, but it's simple. I will trust and run it. Curl is not installed. No problem, I'll install it. Oh, I don't have sudo either. I go back to root to install both. That's how it is with the installation of a minimal version of the system. But minor gaps can be filled. It was simple. Let's go back to Ollama and re-execute the installation command. This uses sudo, so I need to enter my password. Download has begun, so we have a moment to take a summary. From the beginning of the video, I downloaded Linux and we burned it to a flash drive. Then I installed Debian Linux on an old PC with a Ryzen 9 and 64 gigabytes of memory. I connected to it via SSH, created a dedicated user, and installed the missing packages. And now Ollama is installing. I see that the Ollama service has already been started. I see that the GPU has been detected, which is rather strange, but we'll see later. Let's check the Ollama service. This is enabled and running. I will turn it off and deactivate it. I want to run Ollama in the terminal to have full control over it. Although, of course, eventually I will probably also enable it as a service. And disabled. Alright, I have everything to get Ollama up and running and download the first LLM. But I'm going to do some screen ordering at first so that I have two terminals side by side. Let's start Ollama in the left one. Here is summary of commands. I need to run Ollama serve. While Ollama is starting up, in the right terminal I log into the sandbox. By the way, in the left window Ollama reported that there is no compatible GPU, so processing will be exclusively on the CPU. That was the point. x86 fully computing LLM. Let's list all running models. As expected, nothing. It's high time to look at what models Ollama supports. There is a separate section on their site with models. It starts with the king of open source, Llama 3.1, but the list is actually very long. As you can see, open source is an important part of AI development. I'll focus on Llama today. The model comes in three sizes, 8, 70, and 405 billion parameters. We'll start with 8B and specifically with its quantized 4-bit version. This information is also visible when I look into the details of the model. What this means, I will tell you in a moment. For now, I'll focus on the installation. Here is a command, I'll use it. And that's all that needs to be done. Installation is extremely easy. The model download begins. It's a large file, so it takes a while to download. As you can see, even the 8B model is almost 5 GB, and it would be bigger if it wasn't quantized. So what is this process? Well, a neural network is in simple terms a collection of artificial neurons that are connected. Each connection is characterized by a weight, which is simply a certain number. The network's processing involves multiplying the content of the neurons by the weight. In the original version of the models, the weights are floating point numbers with very high precision. Therefore, for the processing to make sense, you need devices that can operate quickly on such numbers. CPUs are poor at this, but GPUs are already great. It has been noted, however, that as we reduce the precision even very much, the model still retains much of its intelligence. And this reduction of precision is the process of quantization of the model. In the meantime, the model has launched. Let me say hello. It responds pretty quickly, but it doesn't admit to being Ollama. Indeed, the model is Llama and not Ollama. Point taken. I guess I can ask something that requires some knowledge. Let's see if Llama 8B knows anything about SAP Web Dispatcher. Yes, it's beginning well. True. Okay, we got it. I don't think anyone can doubt anymore that local intelligence can be run very quickly and very simply, even on an inexpensive computer. Consider that this model doesn't even have 5 GB. After all, now practically no one buys computers that have less than 8 GB of RAM. This just goes to show how amazing a road we've come in recently. Mission accomplished. Intelligence for all. This, of course, also has downsides, especially for smart people. Intelligence loses its value. Sad, but true. But we are here to focus on technical things, not philosophy. Command line is not convenient for everyone. Most people expect the interface that ChatGPT has accustomed us to. This is where another open source project will come to the rescue. Open WebUI. At this point, it is worth noting that all the products we use are open source. Linux, Ollama, Llama, and Open WebUI. I am looking for the homepage of this project. I would be interested in how to install, so the Getting Started section. You can see that they recommend Docker. I will have to install it first. This is the advantage of using a separate sandbox. I install what I want. I'm searching the Docker. The second link seems to be relevant. Yes, I'm in Install section. My operating system is Debian, so it's supported. I need to quickly review the documentation. Installation should not be complicated. My version is 12, so everything is correct. They advise removing old unofficial packages, but I have a new minimalist system. They recommend installing by adding a repository. Quite an elegant solution. I'm starting with the part related to authentication keys. They are needed to confirm the integrity of the software before installing it. This is a standard part of the repository. The second part adds the repository to system software sources, and also updates lists of software from repositories. Configuration part is done. Docker repository has been added to our system. Now, remaining step is to install required software packages from the repository. Obviously, this is one-time action. Docker is installing. As you can see, there are some dependencies. Even quite a lot of dependencies. And done. I can test it. And see if Docker service is running fine. Yes, it is. Docker is used for containerization, so running programs in kind of isolated environment. I will be running Open WebUI as a container. I'm going back to this project's page to copy the command needed to download and run the container with WebUI. This is the command. And this is an error. My user does not have the right to access Docker socket. I know this error. The easiest way is to add my user to Docker group. Of course, I also have to log in again for it to be effective. That's right, I am a member of the Docker group. I can now repeat the command that creates the container. At the moment, the container image is downloaded from the repository. As you can see, it is not small, and that is why it takes a while. Such is the nature of containers. Due to their character, they are sometimes a bit oversized, but it's really a clever technology. Completed successfully and probably even works. Looking at the command, I expect it is listening on my sandbox on port 3000. Bingo! It works! Even this is a local service. I need to create an account. Just simple data. Email can be even fake. Password is important. The account has been created, and I'm logged in. I need to select a model. No model is visible. WebUI should already see connected Ollama. Maybe something is wrong with the connection. Let me check the configuration. I need to go to admin settings. Here are connections. Connection is defined, but it seems it doesn't work. Let's see if Ollama really listens on this port. I'll use ss command. Yes, it listens on the right port, but on wrong interface. 127.0.0.0.1 means that this is on localhost only. Docker is formally an external address, so I have to convince Ollama to listen on all interfaces. I can do this using an environment variable Ollama_host. I need to restart Ollama. Let's check if it listens on all interfaces. Yes, asterisk is okay here. Now I can again check connection with Open WebUI. Let's verify the connection. Yes, now this is fine. I can open a new chat. This time my model is visible. I can ask a complex question. Something about SAP. I will ask about useful basis transactions because I created a video about this recently. Great, it works. The speed of response is not bad either, isn't it? But I don't like one thing. Let's wait for confirmation. Unfortunately, here we have a great example of hallucination. The answer may look very reliable to someone who is not familiar with SAP. The transactions are real, but their descriptions are not anymore. but this is, after all, the smallest model and additionally strongly quantized. Well, okay, I don't like the answer, but that doesn't mean the model can't be useful. On the contrary, for many applications it can be good. Maybe also not for generating programs. But why not? I will try. I'm asking about the same ABAP report as always. Error. I need to choose a model. Now it's fine. I like that Open WebUI formats the code like other modern chats do. I don't want to test the report today, but at least Llama knows that table USR02 should be used here. Not bad. I think that another experiment worth doing would be to install a slightly better model. Maybe even the same size, but a little less quantized. I could expect a bit better answers and less hallucinations. I'm going back to models list on Ollama website. Again, Llama 3.1. I see only 3 models in the list, so I must press View More. I now have access to a much longer list. I am interested in the 8B instruct model with quantization acceptable to the CPU. Q8 would be ideal. It takes 8.5 GB, which is almost twice as much as the 4-bit version. I copied installation command to the clipboard. Before I run this, I can check memory utilization. My computer has 58 GB available memory because Llama 8 BQ4 is running, but this is much more than enough. Let's run this now. I accidentally copied the memory size instead of the model name. I am already correcting this. Now it's better. Llama 3.1 8B instruct with 8-bit quantization. Downloading 8.5 GB takes a while, more than a minute. I won't speed up the connection rate, but using the magic of cinema, I can accelerate the video so that viewers don't get bored. And there you go, downloaded. Model is running. I could ask a question, but I quit. Instead, I can go to Open WebUI and create a new chat. The model is not visible on the list. Let's try to refresh the page. Yes, now I can choose my new model. I can see which is which not only by name, but also by comparing sizes. Let's try to see if this model is better by asking the same question as before. I want to see if it has knowledge of SAP transactions and if it will hallucinate. However, this is quite specific, niche knowledge. It began to respond, slightly slower than the 4-bit version, but still fine. More important is quality and hallucinations. Let's wait a while and see what the final answer will be, because the beginning is not bad. Unfortunately, this time we also have a beautiful hallucination. It's hard to even say if the answer is better than before. I think in this case it is a similar level, but perhaps the tests of small models need to be based more on general knowledge and the ability to make logical reasoning, rather than a test of specialized knowledge, which is something small models probably won't be good at for a long time yet. I am asking a logic riddle, or rather a mathematical problem that requires step-by-step reasoning, and even for humans can sometimes be difficult to understand. We'll see how it handles, whether the answer and reasoning will be good. Again, I need to choose a model. We see a step-by-step approach and with a definition of the problem at the beginning. Very good. Yes, the data was summarized correctly. Still good. We have assigned variables A and E to the girls' ages. A good approach. Based on this, it defined the equation. It seems correct. A minus E represents the age difference between the girls, which is key here to solving the challenge. The equation also correctly describes the entire content of the problem. In step 4, we have the substitution of Anna's age into the equation. Step 5 is to simplify the equation by getting rid of the parentheses on the right side. And finally, step 6 is to solve the equation. Yes, the result is correct. Very good. The quantized 8B did very well with this task. Let's see how big a model we can use on this computer. First, however, I need to remove 2 models that are already running. I want to use the memory to the maximum, and the current models probably take up about 13 gigabytes. Ollama RM removes a model. I need to specify both of them. Now I will go back to the list of models on the Ollama website. My computer has 64 gigabytes of RAM, so I'm interested in a model that will fit with some margin. The Llama 70B is a good candidate. The important thing is to choose an instruct version with the right quantization. 6-bit seems to be just right. The model is less than 60 gigabytes. As always, I copy the command to my clipboard. Command pasted. This time it will take even longer than before. When starting to work with local LLMs, you need to be aware that these are large files. On a 10 megabit connection, downloading would take not 8 minutes, but over 10 hours. Let's use magic once more and finalize download in a moment. This is what traveling at the speed of light looks like. And done. I can quit and go back to my WebUI. But first, let me maybe start top to see CPU and memory utilization. As expected, around 58 gigabytes is used. I will now set the windows side by side. The model is not visible, so as before I need to reload the page. Now I can choose it. I can ask the same niche question to compare level of hallucination. Already you can see that it takes longer to start a response. Well, yes, you can see that this model on my computer will not be a speed beast. Let's look at the CPU utilization by Ollama process. Almost 1200%. Although it may seem that the system is not fully loaded because it has 24 threads, but it is still only 12 cores. So I assume that the 1200% used by the Ollama process is taking all it can from the CPU. It also addressed 59 gigabytes of memory and probably utilizes most of this. Perhaps this computer could still be sped up by tweaking the memory clock, because surely the settings are not optimal. However, it is clear that we are close to the end of the potential. Is the model at this speed of responding useful for anything? Well, chatting with it would rather not be one of the pleasant ones. But on the other hand, the use of the API by some program could make sense if it found an application. However, for most purposes, it is not useful. Let's speed up the video one more time so we don't get bored waiting for the answer, and let's at least see what the quality of response is. Yes, it must be said that it is incomparably better than the smaller models. Although I see some confusion or a slight hallucination here, this answer is much closer to the truth than the previous ones. Okay, this video is very long, so we'll finish for today. But before we get to the summary, here's a little advertisement. If you want to support the channel, just subscribe and share it. Nothing more. The end of advertisement. Now a summary. As you can see, intelligence in your basement is not just a slogan. It's a feasible reality. Intelligence is becoming more accessible and cheaper. What does this mean for us? From this point in history, will the feature that caused us to take over the world begin to slowly fade in us? People have had similar doubts with various inventions, and almost every revolutionary change gave cause for rejection. Suffice it to say that Plato criticized the invention of writing, fearing that now memory is no longer necessary and people will stop practicing it. And I guess nothing bad has happened to us, right? Will it be the same with artificial intelligence? Time will tell. May your intelligence always lead you in the right direction. See you next time.